Hello everyone, welcome to Clashing Coder. So in this video we will see the question 189, that is rotate array. This question is one of the most liked question on the lead code, and it has been asked for the interviews for the Amazon, Flipkart, etc. So it can be asked in basic interviews also and for the FANG companies also. So let's see the problem statement, then I will explain you how we can solve this question in three different ways and how we can optimize it further. So let's see. So given an array, rotate the array to the right by k steps, where k is non-negative. So that means, as the question is, you can see rotate array, so we have to rotate the array towards the right side by k steps. So let's see. So first of all, you can see the follow-up is actually try to come up with as many solutions as you can. So there are at least three different ways to solve this problem. So I will show you the three different ways. First will be the optimal, first will be the naive, then the better, then the optimal approach. So this we can see, can you do it in the O of one extra space. So we will see this also. So let's see the example and how we can solve it. So actually you can see, first of all, we are given the input array and then we are given the k. So we have to rotate the array towards the right side by k steps. So actually this you can see, that means 3 steps. It is given 3 steps, k is equal to 3. So let's see, this is the array. So when we rotate it to the right side, so it is actually a circular. You can assume it to be circular. So this 7, you can see this will come to the first or the starting of the array when rotated one time. Then you can see when we rotate it the second time, then this 6 will come to the starting of the array and this 5 will come to the position of 6, and all the elements will be shifted one index further. And then you can see when we come towards this 5, then this 5 will be also shifted, as the number of steps is 3, or we have to rotate the array 3 times. So in this example you can see we have to rotate the array 2 times. So that means the 3 and 99 will come to the starting of the array, and this -1 or -1 and -100 will come to the ending of the array. You can see the size of the array will range from 1 to 2 raised to power 2 into 10 raised to power 4, and the elements will vary from -2 raised to power 31 to positive 2 raised to power 31 minus 1. So let's see how we can solve this question. So actually if you are asked this question in an interview, so let's see the example first of all, then we will see how we can solve this question. So in this example you can see this is our array and these are the indices. These are actually the indices, and we have to rotate the array 3 times. So if it is given that we have to rotate the array 3 times, that means that in this given array, this last element will come to the first position. So as I told you, you can assume it to be a circular array. So it will be actually like this. You can see this will come to this point. So we will the elements over here, when we increase their index and it becomes greater than n, so it will come to the 0th index, the starting index, and these elements will shift by one position to the right side as it is given. So let's see. So in this example we have to rotate it by 3 times. So when we rotate it by first time, so it will become, you can see, 8, then 1 will come here, then 2, and then 3, then 4, and 5, you can see, then 6, and then 7. So 7 came at the place of 8. Now again we will repeat this step. So now 7 will come to the starting, and all the elements will shift one position ahead. So 6 will come here, that means 5 here, okay, then you can see 5 here, then 4, 3, sorry for that, 3, and then you can see this 3 and 2 and 1, then here it will come okay, 7, then it will come, okay, so here is 8, then here it will come, sorry, then you can see 7. So similarly when we like rotate this again, so we have rotated it 2 times. You can see now we have rotated it 2 times. So when we rotate it 3 times, so it will become, you know that, so it will become 6, 7, 8, and 1, 2, 3, and similarly. So now we have rotated it 2 times. So this is our question asking for, and now let's see how we can solve this question. And also here it is given that k can be also, it is not given actually, but you should know that, you can see here k can be greater than 10 this n, the length of the array. You can see k is given from 0 to 10 raised to power 5, but the length of the array will range from only 1 to 2 raised to power 2 into 10 raised to power 4, which is smaller than k. So k can become larger. So for example, if you are given an array like this, okay, let me write it. So if you are given an array like 1, 2, 3, so okay, and you have to rotate the array, that means 4 times. So that means your array length of the array is only just 3, but you have to rotate it 4 times. So for that what we can do is, instead of rotating it 4 times, we can take the modulus or this number, that is k, modulus n. So n is our, you can see, 3. So n is 3. So 3 modulus 4 will be actually 1. So that means we have to rotate array only 1 time. How is that, now you will think? So you can see when we rotate it 1 time, so it will become, you know that, let me write it. So it will become, when we rotate it 1 time, it will become 3, okay, then 2, 3, 3, 1, 2. When we rotate it second time, so it will become this 2, 3, and 1. When we rotate it again, it will become 1 and 2 and 2 and 3. So now when you see we have rotated it 3 times and we have rotated 4 times, so it will become again, you can see, 3, 2, and 1, which is the first step that we are getting. sorry, it will be 3 1 and 2. So which is the first step that we are getting? You can see 3 1 2. If we rotate it one time or if we rotate it 4 times, we will get the same value. So that is why if k is greater than n, we will every time we will take the k modulus n to make it only rotate certain number of steps, that the answer becomes equal to k. So you can see this is correct. Now let's see how we can approach this using the naive approach. So let's see. So in simple array that you are given, so it is given in the question that you have to rotate it k times. So why not every time you run a loop for k times and you rotate shift every time every element one time, okay, every element by one position for k number of time. So what we will do is, first of all, as I told you, we will have to take the mod of k, so the k does not get larger than n. So then we will take we will have to initialize temp and previous variables. So when you are shifting the values, so you will have to save this value somewhere, and then you will have to save this value somewhere. Then only you can add this value. So this value is also stored, then only you can update this value. So that is why we will take a temp and previous variable, and we will run a loop for I is equal to 0 to k. So it will run till k times, that means 3 times it will run, 3 times it will rotate the array. So now this logic is for rotating the array, okay, this logic is for rotating the array. And you can see first we will save the previous value. So previous value is actually 4 or 7. You can see 7 will be saved in the previous variable, it is n minus 1. And when we start this loop, our temp variable will show this value, because when we write the 7 to this position, then 1 will get lost. So we'll have to save 1 somewhere. So we'll save 1 here, and then we will update this position, this 1 value to 7. It will be updated to 7 in this condition, and previous value will be saved as 1. So this previous will remove, and this 1 will be saved to the previous. Now again for this also it will run again. We will save this value in the temp, so it will be saved here 2, then previous will overwrite the 2's value to 1. You can see it will be written as 1. Now previous will be updated to 2. So again similarly this loop will run for n times, okay, n times for every k iteration. So that means it will rotate the array for k times. So the time complexity will become n into k. That is why it is a naive approach, and the space complexity will be actually of 1 only. This I have used this for the representation, but the array will be overwritten because we are saving this value and this value and overwriting them. We are not using an extra array, we are using just a simple variables. So that is why. So how it is naive approach, as I told you, we will have to run the k times, we will have to run the loop k times, because we have to rotate it k times, and for every loop we will shift the element by one position. So that will take O of n complexity, O of n into k complexity, and the space will be of 1. So let's see how we can optimize the solution further. As I told you, we were not saving any elements to an array, different array, we were only using the variables. So why not, when we are iterating, we simply save the elements into the new array on their position, which will be they will be on after k iterations, or the k steps. So let's see. So you can see first we will initialize a new array. So this is a new array that we are having, and we'll modify all the elements in this array and then save it to the original array. So for 1, as I told you, we have to rotate it k times, so that is k is 3. So for 1 its position is 0, so it needs to be on. You can see how we can find its new position. So its new position will be the current position, that is 0 plus k modulus n. So k, so the k is 3, sorry for this handwriting, so it will be actually 3, and 3 modulus n. So n is here, I have 7. So 3 modulus 7 will be 7 or 3 only. So that means this 1 needs to be at the third position or the third index. So it will come here. So this will simply take off extra space, actually of n space, and the time complexity will be optimized, because we have to only traverse the array 2 times. That will be actually 2 into n, or n plus n, you can see. So how we are doing this, you can see we will iterate over this array, and we will update the elements value to, you can see in this new array, you can see I will be this, if we are on this index, okay, 1. So we are on this index, let me write it here. You can see this 1 index. So how we can find its new position will be simply the current index, that is 0 plus k. K is 3. So 0 plus 3 will be actually 3 only, and we have to take mod of n, because when you are at this index, when you are finding for this value, you can see 6 plus 7 will become greater than n. So how you can map it to the temp array, which is of size n only. So that is why we'll take mod of k. So when we take mod of k, it will be obviously mapped to this. So it will be between 0 to 6 only. So that is how you can map this, and you can update all the elements in the new array. And then at last, as you don't have to return anything in this question, you don't have to return anything, you have to update the array in place. So that is why you will have to run again a new loop, and you will copy all the elements of the temp into the original array. because you don't have to return anything, you have to update in place. So let's see how we can optimize this solution, because it is taking O of n time, which is obviously great. But how we can optimize this space, because you can see there is a follow-up. This question is actually solved, but the interview will also ask you to solve it in O of 1 space, because you are wasting space, because in this solution we were not using the space, but in this solution we optimize the time complexity but are using space. Why not combine these solutions or develop a new observation? So let's see. So you can see here it is given, could you optimize this with, so that is why I am showing this. So let's see. So you can see I have updated the example. So you can see in this the k is 3 and this is our array and these are the indices. So these are the indices and this is our input array and this is our output that we have to generate, and we have to rotate the elements by k positions or k steps and form this array. So now let me draw something, then you will be able to visualize this, how we can solve this question. So actually if you see carefully, this is the given array and our k is 3. If you see, this 3 elements from the last array are coming towards the first 3 elements. You can see they're coming on place of the first 3 elements in the array, and the first this elements, that is n minus k elements that are left, they're coming after these elements. And you can see this is forming something. So you can observe this carefully, how now you have to, like, you know that the number of elements that are on the last position. Okay, if k is 2, so we'll take the 2 elements from the last side and they will come towards the first element. So they will come before the first element and the elements before them will come after them. So how we can achieve this thing? So let's see how we can achieve this. So if you see carefully, now let me erase this. So we know that we have to bring these 3 elements in the front of the array. So why not to rotate this array? Because to bring these elements towards the starting of the array, we will have to rotate this array, the reverse this array actually. Then only we will be able to have them at first, because they cannot be sorted. So actually you can say they so we will let's see. So when we reverse them, actually you can see we reverse them, so it will be 8 7, okay, 6 5 8 7 6 5 4 3 and 2 and 1. Now you can see when we have reversed this array, you can see when we reverse this array, it will become this 8 7 6 5 4 3 2 1. So it was like 1 2 3 4 5 6 7 8, then it has been reversed. So now you can see it is like bit similar to this array, output array. So this is our output array, this is what we have to achieve, and you can see this is our array when we this original array that we have rotated. So now to achieve this array, we have the k value. Okay, k is 3. So what we can do is we can rotate this element or reverse this elements again. You can see this 8 7 6 is at its correct position actually, but it should be in a reverse position. You can see 6 7 8. So they 3 elements should be coming at the starting only, but they should be in reverse order. You can see 6 7 and 8. So why not reverse this? So if we reverse this, it will become 6 7 and 8, and now these elements are left. You can see these 5 4 3 2 1, they are also in reverse order of what they should be in, 1 2 3 4 5. So why not reverse them also? So when we reverse them, it will be 1 2 again 1 2 3 4 and 5. Now you can see 6 7 8 1 2 3 4 5. So now this is our output array and this is our output the array when we reverse the array in three different types. So now you can see we have obtained our output. So this is what the observation that interview is like searching for, if you can observe this or not. So let's see how how we can code this. So let's see. So you can see this is the array that we were given. So we will simply, first step that we have to follow is k is equal to k modulus n. As I told you, k can become greater than n because k is of power n raised to power 5, but the n is only of power n raised to power 4. That is why you will have to take the modulus of k with n. Now as I told you, we will have to reverse the whole array first of all. So when you reverse the whole array, it will become 7 6 5, okay, 4 3 and 2 and 1. This step is reversing the whole array. Now as I told you, now we have got the elements in the starting position, the ending elements, the k elements that should be at the starting position, but they are not in the right order. So to do that, what we'll do is, now we'll first we have rotated one time, okay, reverse the array the one time, then we will reverse the array second time, that is not full array, the k elements. So it will, you can see 0 to k minus 1. Actually k is 3. So here the indexing is 0 based, so we will have to write k minus 1. So it will be this. So now we will rotate this or reverse it. You can see it will become 5 6 and 7. So we have got this array. It is till this point we have this array. Okay, now you can see these elements should be in correct order. It should be in 1. You can see 1 2 3 4 5. So now we will have 1 2 3 4. So we will have to reverse this again. So these elements are starting from, you can see, k. They are starting from k is 3. So they are starting from k and are till n minus 1. So now we will have to rotate the array from numbers. You can see this array that we are given and the k till n minus 1. So k will be actually this and n will be this. So now you can see we will get our output. This will be k, this will be 5 6 7, and then we'll be having 1 2 3 and 4. You can see this is our output that we were expecting. So let's see. So actually the space complexity is also, you can see, is of 1 only, that is constant space, because we are rotating or reversing our array in place. We are not using any another array, and the time complexity is just O of n, because we are traversing the array for reversing it. So it is reversed only 3 times. So you can see, so the time complexity is 3 of n, which will be approximately n only. So you can say n. So time complexity is n, which is optimized further. You can see this naive approach was taking n into k time, but we have optimized this, and the better approach was taking the same time, but it was taking of n space, which we have also optimized. So we have combined these solutions and have made a optimal solution. So let's see the code for this solution actually. So I will also provide the code in the description. You can see. So this is the function that we are given, rotate function, and this is actually the reverse function that I have made to reverse this array. So you can see in this rotate, first of all, let's see. So in this rotate, as we have to take the length of the array, so length of the array will be actually, you can see, numbers dot size. Then we will take k is equal to k modulus n to map the k to the value less than n, because k can get larger than n, you can see, from the constraint. So you should always note this constraint also to note these conditions, to find these conditions. So now you can see, first of all, we will reverse the array from 0 to n, that is n minus 1, that is whole array. First of all, we will reverse the whole array, and you can see this reverse function is simple. Actually, you can understand this. So do remember that when we pass this array, so you have to pass it by reference, because it should be updated in place. You're not passing a new array, you are passing the original array. So you can see this, first of all, we will pass the starting index and the ending index. So till where, from where to where we have to rotate the array or the reverse array. Then we will run a loop. While this left side is less than the right side, we will simply swap these elements. I hope you know this code. Actually, this is simply reverse code. Then you will reverse the elements that will be starting from k till this k position till n minus 1. You will rotate these elements. Then you will reverse these elements. So you can see these elements will be from 0 to n k minus 1, 0 to k minus 1, and this will be from k to n minus 1. So simply you will get the answer. Let's see some of the solution. Then you can see here we made this code actually. So in interview, it is preferred that you make this code actually yourself, but if you don't if you want to use the STL features of the C++, then you can simply do that reverse. You can use reverse function. You can see you can use the reverse function. As we have been passed a vector, so you can simply write numbers dot begin and numbers dot end. So this will rotate whole array. So now for reversing the array from, you can see, the starting segment of the array, we will have to do numbers dot begin and from till where. So numbers dot begin plus k. Numbers of begin will be pointing at this point, and plus k, that means 3, will be pointing towards this point. So it is actually pointing to this. So similarly, when rotating in the last segment, it will be numbers dot begin and plus k. Numbers dot begin plus k will be pointing to this point, that is 3, and numbers dot end, which will be pointing to the end. We will rotate that. You can see we can submit like this also. It will be accepted. You can see. So let's see. You can see it is actually same complexity. So I will also provide this code in the description. It is fairly simple. So I hope you like this video, guys. Do like this channel and subscribe this video for subscribe this channel for more such videos. Thank you for watching, guys.